In this video, we're going to go through a couple of examples on how to read equations that we have solved. So in this one, we're going to work through question number 2, and it asks, solve the following equation for the variable time. So what I want to notice first is that time is on the bottom of the equation. Any instance we are solving an equation and the variable is on the bottom, we have to move it to the top. So on this side, we really could have written speed as speed over 1 to show that speed's on the top and then the 1 is on the bottom, but you don't have to do that. So what I'm going to do is I'm going to move time from the bottom up to the top. We are cross multiplying through this equal sign. Why do I do that? Because it's asking me to solve for time, and time's on the bottom, so I move it to the top. Once we move that variable to the top of the equation, the next thing that we need to do is make sure it's by itself on that side of the equation. Well, it's clearly not by itself. It's right next to speed. So I'm going to move speed from the top left to the bottom right. We cross multiply. So now, when I rewrite my equation, time is equal to distance divided by speed. We must first solve the equation before we can answer whether those variables are directly proportional or inversely proportional. So the first question asks, are time and speed, how are they related? Well, we have two options. If the variable's on top, they're directly proportional. If the variable's on the bottom, they're inversely proportional. What that means is if speed, because it's on the bottom, increases, it's going to make time decrease since it's inversely proportional. So time and speed are inversely proportional, and time and distance are directly proportional, meaning if distance goes up, it'll also make time go up. On the back side, here's a problem asking us to solve for mass 1. Mass 1 is here. It's already on top of the equation. Do not try to move it over. There's no reason to move it, because if you were to move it, you would cross multiply it to the bottom, and now it wouldn't be on top. So you leave it right where it is. But we need to move everything else. So G moves down to the bottom. Distance squared, I'm going to abbreviate and just put D squared, goes from the bottom to the top. And M2 goes from the top to the bottom, and I changed the way that I wrote that. Instead of writing mass 2, I just put M2. So now mass 1 is equal to our force multiplied by distance squared, all divided by G and M2. These are sometimes written as dots, sometimes just as X's for multiplying, sometimes as little stars for multiplying. So now it asks mass 1 and force. Mass, now that I've solved the equation for mass 1, I can see what kind of proportionality. Well, force is on the top, so those two are directly proportional. If force goes up, it's going to make M1 go up. Mass 1 and distance are also directly proportional, because distance is on the top. So if distance goes up, M1 also goes up. I hope this helps in understanding, once we solve an equation for the unknown variable, how to read the equation in terms of the other variables that are involved.